Hello friends, welcome back to my channel. As part of this video, we are going to see how we can deploy infrastructure on AWS using Terraform. Now we are going to see how we can deploy Kubernetes or EKS on AWS with Terraform. EKS is nothing but Elastic Kubernetes Service, which is managed service from AWS itself. So it's just Kubernetes cluster application. And the prerequisite to do this, we need a Terraform script. We already know what Terraform script is and what are the details it contains. Basically, how many EC2 instances we need for our Kubernetes cluster, and security groups and IAM roles and policies and auto-scaling group details. Everything has to be defined. And once we have already Terraform script, you need to install Kubectl tool also on your laptop, because to deploy your applications or maybe pod autoscalers and cluster autoscalers. So for this you need a Kubectl tool on your laptop. And AWS IAM authentication tool, this is another tool that is required, because when you are managing Kubernetes cluster on AWS, you already need to manage AWS IAM credentials to provision and update the cluster. By using AWS IAM Authenticator for Kubernetes, you avoid having to manage a separate credential for Kubernetes access. Yeah, basically, if you are building a Kubernetes installer on AWS IAM Authenticator for Kubernetes can simplify your bootstrap process. Basically, it will copy all your security and credential classes, so it will ensures that Kubernetes cluster will have the access to the AWS API, so that whenever it needs another node, other image to deploy another node on your cluster, so it must have the access to the AWS API, so that it can fetch the required images and it can deploy it as a node. So we need this tool. So we are going to see how we can copy those security and access details from AWS cloud to our Kubectl tool, then we can deploy the application easily. Yeah. What is Kubernetes? Of course, whoever watching this video might be having the basic idea of what is Kubernetes. It is a container management system to deploy, which will be used to deploy your containerized applications, basically Docker images, so that you don't need to have managing, whenever the load increases, whether you don't need to manually deploy your new application. So Kubernetes will take care, auto scaling and auto scale that, and how it can manage, we are going to see it. And what is EKS? Yeah, EKS is nothing but Elastic Kubernetes Service, which is managed service from AWS cloud itself. So there is no much difference, but when you have Kubernetes on your on-premises or cloud native environment, you will have the master and worker nodes. But here in EKS, you don't see the master node when you deploy your EKS cluster on AWS. Basically, it's a control plane, which is part of AWS cloud services itself. But you can see the worker nodes when you deploy your EKS cluster on AWS. And how EKS is different from Kubernetes? K8s, of course, K8s is nothing but a Kubernetes, because it's a abbreviation form of K8s, but you can find what is exactly K8s. And how it is different from it. Yeah, when you have Kubernetes installed by yourself on your cloud native environment or your on-premises, and you need to manage it. That means when there is some crashes happens and you need to rerun and redeploy Kubernetes cluster, and also when there is a new version comes up, you need to apply the patches. So it's a hassle thing, you don't like to manage and do such things. So but when you using cloud providers like Azure or AWS, they will have all this process to apply the new patches, to upgrade it to new versions. So it will be done automatically. They have their automation processes to manage such things. So you will be free from all those stuff when you use Kubernetes on AWS cloud or Azure cloud. That is the difference, but everything is same as how it works on your on-premises. hands-on demo. Yeah, that's then let us go into how the actual demo, how we are going to deploy Kubernetes cluster using Terraform on AWS. We will go through that. Deploying applications on EKS. It is same as how we can deploy applications on Kubernetes cluster using kubectl tool. So we are going to use kubectl tool to deploy our applications on EKS cluster. And yeah, let's go through that each and every step. The first one, I'm going to show you that how the actual Terraform script looks like. Not this one. Yeah. I have this project Terraform scripts. So basically this is the module I have created for Terraform script. So EKS cluster, we go through this. So this is the resource we have defined here. It's AWS EKS cluster. This is the mandatory logical name, that actual name, and this is the demo cluster. You can name it anything, you know. This must be should be same as, because it's a logical name defined by the AWS itself. Demo cluster you can define. So I named it as a demo cluster, and variables as a cluster name, and role URL and IAM roles we have to assign to this. There is some problem here. Now we want to deploy EKS cluster on AWS. Before doing that, we'll go through the script, what it contains exactly. Let's go through the first as a providers.tf. This is the script actually which will contain the provider in AWS. So if it is Azure, means we have to mention Azure, and and the region. So region, we are going to use US East 1 region, and data like which region and current and availability zones. These are very common, and if you want to know what is each and this attribute definition, go through the document on Terraform. And if you go through EKS cluster, so how we are going to define our EKS cluster, you have to mention the resource and then AWS EKS cluster. This is the logical name. It should not be changed. This is the name actually that we are going to define for our actual name, whatever we wish. So I defined it as a demo cluster, and the name is so cluster name and the role ARN. So this is actually AWS IAM role that is defined in the IAM TIFF. Even you can go there using this, and it will show EKS cluster and IAM. Here you can see IAM role, which is defined name as demo cluster role, and also we have defined some policy for this, like allow. Yeah, if you want to know what exactly this policy abbreviation, like what is the definition of this policy, just go through the documentation on AWS. You'll have the full details. I don't want to go through those in depth. And the resource IAM policy attachment, we are attaching the policies, the required policies for the EKS cluster. Those policies needs to be applied on IAM role. So this script will take care of applying those policies on specific IAM roles, which needs access to the AWS API from EKS cluster. Yeah, these and all policies applying on it. IAM role policy, create service, linked role, yeah, and also worker nodes. So if you have the worker nodes on EKS cluster, so how to get the access from worker nodes to the AWS API, like because AWS API contains the control plane, which is actually master node for our EKS cluster. And what and all we can look at, of course, security groups. Yeah, we have to mention security group as a resource on its name. Terraform cluster description and VPC virtual private cloud, like egress, like how the traffic should go from node to other nodes in the cluster. Yeah, this and all security group rules. I just followed the documentation that has been given on Terraform website itself. So yeah, so this is the script. Actually, using this script you can deploy EKS cluster on AWS, and we are going to execute commands how we can deploy this script, how we can execute this script to deploy our infrastructure. So let's come out from the presentation mode. Okay, let's go to the terminal. First, as I said earlier, we need to first execute the Terraform init method. So it will initialize the Terraform script on my laptop. The second method, the second command that we need to execute is Terraform plan. As I said earlier, it will check our script, what and all infrastructure that needs to be deployed, and it checks also if there is an error. If there is an error, it will tell us, so we need to correct it. So it will show you the execution plan, basically, like how many components it's going to be deployed on AWS as per the script. So it's complete plan, you can review it and you can modify if there is something that needs to be changed which you don't want. So it is going to deploy 37 components. So that final command that needs to be executed to deploy your infrastructure. Once you run this command, it will check, it will refresh the state, and it will ask you the confirmation to say yes. So once you say, it will start executing all the scripts that has been defined here one by one. So it takes around 10 to 15 minutes to finish this job, and we'll come back and we'll check what happens after this. If you see that my AWS console, we don't have any EC2 instances or anything, or AutoScalers, you don't see anything. I will show you. So once the script done its job, you can see that the required worker nodes would have been created, and also auto scaling group. There is one manual thing that I need to do here, because I have to apply policy once our infrastructure is ready. I need to apply some policy for our auto scaling group. I could have put that policy as part of the Terraform script, but I don't know exactly, but it was not applying. I am getting some errors, so I am doing that work manually. Come on. Yeah, it's a bit slow here, internet, because of coronavirus. Everyone is working from home, and the network bandwidth is very low in the street, and yeah, that's otherwise it was very fast. See, I don't have any running instances currently, and I will show you that. Of course, it will show that I have one user which I have created to access this security group 1, and maybe so there are no any running instances. Like that, I need to give the confirmation to say yes, to go ahead. Yes, I given the yes. So it will start executing all the scripts. I want to tell you one more thing, one more important that I have missed it to tell you. Yeah, AWS auto-scaling group. You need to define this if you want to scale up your worker nodes. Like so maximum size I can give, you can give like 5 or 10 or 20 as your wish, but it depends on your application size, and minimum should be 2. So it's going to be deploy 2 worker nodes for us. Maximum is 5, so more than 5 it will not, because you don't want to get more usage bill. So depends, my application is very small, so I need just, if it is more traffic and there are 5 nodes are more than enough to process the request, which if my application is getting more requests. So that is the purpose of this. And yeah, after finishing this script, this auto scaling group also will be created as a demo, and I want to apply some policy so that this auto scaling group can access the AWS API, and it can fetch the new Amazon images or Linux images for the new worker nodes whenever it is required to scale up the cluster. So it's going on, and yeah, let's finish it. I'll come back once the job is done, and I will show you that the new instance. So I have 0 running instances. Once the job finishes, it will show you that the running instance how we have. Now you can see that the Terraform apply command has been done its job. You can see that the context details and all, and what is the name of the EKS cluster name. That's what we have given in our Terraform script. It is a Terraform EKS demo, and the kubeconfig details like certificates, this and all things, config map. This information that is required for our AWS authenticator that has been deployed as a CLI tool on our laptop. So we need to retrieve this config map from our EKS cluster, and we need to configure it locally so that we can seamlessly connect AWS API from our EKS cluster. So there is a command to copy that script to our local machine, that is a Terraform output and kubeconfig. So you have to run this command to copy that stuff. Then kubeconfig. And also there is one more command that we need to run. That is, I have mentioned it on my GitHub repository. That is, yes, this is. So this command also required, and we need to config our config map AWS auth. This configuration information will be used by our AWS IAM authenticator. So once you done that, it will be copied to our local. So this file need to apply it with kubectl command. Means we are deploying this config map on our Kubernetes cluster so that our cluster can have access to our AWS API services to retrieve the Linux images and to create new nodes. Now even you can see how many nodes has been created by running command from your command prompt, that is a kubectl get nodes. It will show how many nodes are running currently. Usually you can see the 2 nodes. Yeah, this is one. Even you can see these 2 nodes from your AWS console as well. I'm going to show you that. Yeah, see, now it was 0 instances. Now it has 2 instances running currently, and 5 security groups created.